Today's video is brought to you by Solderstick. They have solutions for connecting wires to other wires, terminals, or anything else you can think of. There will be a short video explaining more about them at the end. Now enjoy our regular video. Hey, what's happening, guys? It's October and spooky season is upon us, which means people, at least in the U.S., will be putting out their Halloween pumpkins or jack-o'-lanterns, whatever you call them in your area. And instead of the traditional candle or, a dollar store electronic tea light or whatever, thought we might come up with something a little bit more fun. So what we have here are our components. We have an Arduino Nano. Any Arduino will do. I mean, it doesn't even have to be an Arduino. ESP16, ESP32, any of that will work. We have an infrared sensor, a speaker, 2 red LEDs, and 2 220 ohm resistors. So the LEDs anodes are hooked up to digital pins 5 and 6 on the Arduino. It doesn't matter what pins you hook them up to. I just randomly chose. The speaker anode is hooked up to digital 3, and the output signal from the infrared sensor is set up to digital pin 2. The cathodes from our LEDs go through 220 ohm resistors to ground. So you see the LEDs only get their power from the Arduino pins when the Arduino sends power through those, and that only happens when this sensor sends a high signal out that wire there to digital pin 2. The speaker again just goes directly to ground, and I have pulled 5 volts and ground off the Arduino down here. So what I'm going to do is I'm going to plug it in. I'm going to put this here in front of it, and hopefully it won't see me as I plug it in because it is kind of sensitive. And you can see what it does. Well, there it is. Now you've seen it. The LEDs turn on for a second, off for a second, and this plays a little spooky tune. Alright, that's annoying. You want to see how I did it? Alright, let's go over the computer. Okay, so here's the code for our little Halloween thing. Done a couple things differently than I normally would here, which might be considered sloppy programming, but I honestly don't care. It works. So we defined some pin numbers here. Input pin number 2, that's where our sensor is. LED pin 1, LED pin 2, they're on pins 5 and 6. Yeah, I didn't define the speaker pin here. I did it down here because I decided to add the speaker in later. So that's the way it is. All right, we have variables to track LED state and timing. They're just Boolean variables, on, off, 1, 0, true, false. And we just turn them both on. Then we're going to assign previous millis, store the last time they were on, constant millis. This is how long they're going to stay on, so we can turn them on for a second at a time. Then we have our setup. We're going to tell our pins whether they're inputs or outputs. That's kind of important. So input pin is input, LED pins are outputs, and pin mode pin 3, which I could rewrite as speaker, but I don't care, is on output. So the next thing we're going to do is we are going to read the state of that pin. And if it has been triggered, then the state of that pin will be high. We will update our timing. And then we will toggle the LEDs either on or off, whatever state they are. Putting the bang in front of it tells it to be the other way. Then we'll toggle them to their new states. And then we're going to play a little, that little woo, the little rising sound there to get people's attention. So for I equals 200 to 400, I increases 1 at a time. Play a tone on pin 3 of frequency I, and delay for 11 milliseconds. You can change that to make it however you want. Once it's done, stop playing tunes, put all the LEDs off. Really? That's it. That's all there is to it. It's super simple. I'll put a link to it down below where you can download this code. So like I said, I'll put a link to that code down below to Pastebin where all my code is stored. And if you guys want it, you can grab it. Now, I have this set up on a breadboard. You certainly don't have to do it that way. You could get yourself some DuPont cables, and you could move the LEDs into, the jack-o'-lantern's eyes. And you're definitely going to want to have that guy on the outside, or at least poking through a hole so it can tell when people are coming. All right, guys, that's it. That's all I got for you today. I hope you enjoy, and check out this short video from our sponsor at the end. All right. If you enjoyed this, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all the patrons. Big thanks to our sponsor, Solderstick. Big thanks to Halloween for giving me something to make a video about. That's it. I'm out. Peace. We've all been there, right? We've all spliced a set of wires together and either used some electrical tape or a wire nut or something to connect them together. There's always a better way. If you need them permanently connected, I suggest the Solderstick solder connectors where you heat them up with a heat gun and they melt together. But if you need something a little less permanent, spade connectors. We have a male and a female connector which fit together like so. You crimp those onto the ends of your wires and you look like you know what you're doing. And have you ever come across something like this where the wires have been stripped, focus, and just crushed underneath a screw to hold them in place? Well, time and temperature will cause those wires to move and flex and eventually come loose, which can definitely lead to a hazard. In that case, something like the Solderstick ring connectors are just what the doctor ordered. Crimp these guys on your wire. They have them for all different size wires. Heat them up. This heat shrink will shrink down, giving you a nice insulated connection to your wire that you can then put underneath that screw and have a nice professional looking solution. Solderstick. You can see their website right there, www.solderstick.com. Check them out. See if they have a project or a product that works for you.